Start recording. So, during the last lecture, we have played around with Qt some more, and today we will, of course, continue. Although we will now again take a look on a few more low-level things, so not directly UI-related stuff. To those we will return soon enough. But today we will try to do some things with networking and starting of programs, inter-process communication, stuff like that. Generally, things useful if you want to create more complex software with different components that communicate with each other, or things that are also relevant if you would want to use serial ports with Qt's offered classes. They behave quite similar to sockets in network communication with regard to how to send and receive data. There are of course some differences, but they are not so significant. So if you can use sockets and generally the QIO device elements, then you should be able to also use the Qt serial port class to communicate with some hardware that you want to control in your lab. So we will start a new project for that. Create new project, Qt widgets or Qt console. Let's start with Qt widgets because if we want to add some UI to visualize what we are doing, then it would be easier than having to switch a Qt console application later on. Let's call it networking. Now I'm thinking let's go with a console application. That is, I think, a better option. It's a better fit. If we want to show it graphically, we'll just make a second application and just copy our classes to it. Networking. Let's call it networking. Create. Next. Yeah, this is useful. Finish. And generally, what we like to do when working with network or inter-process communication is to actually have different processes that communicate with each other. That makes the examples much more lifelike or real life. So what we will do is our first application will be just starting other applications, and then we'll be able to make them do things. Although when I think about it, maybe a graphical would have been better. Let's restart again and make a graphical one. Then we can add buttons to start each different component. Create new project. Qt widgets. Next. The name networking is unfortunately already used, so we need to quickly delete it. Zack. Yeah, that would be nicer. Create. Next, precompiled header. Next, this can stay as is. Finish. In the previous lecture, the last year, I just had different manually to be started applications, and that was not so convenient for testing because you needed to use multiple instances of Visual Studio, and each of them requires quite some non-insignificant amount of memory. So for example, this virtual machine here has allocated 16 gigs of memory and 12 gigs are already in use, and we only have 2 instances of Visual Studio. So when we look here, working set, we see that Visual Studio is consuming at least a gig of memory plus all the other accompanying processes, so it really is everything but a lightweight application. So what we'll be doing today is we will be debugging multiple processes with one and the same instance of Visual Studio. That's a much more, let's call it cost-efficient approach, but it requires a additional tool. So Visual Studio, the way it is set up out of the box, when you start it, when you start with it an application, it will only start debugging this application. If this application spawns a child, it will not debug it by default. And there is no switch to change this behavior. So what we need is an extension, which we can get from the online list of extensions. Child process debugging PowerToy. So it's even an extension offered by Microsoft, so they know this is a useful functionality. we can install it, and we should restart Visual Studio for it to take effect. It will allow us to spawn child processes and then be automatically connected to them for debugging, which is quite convenient. Yeah, let's restart it. I think we should have waited until this finishes. Yeah, modify. This takes a second or two. And as soon as it's done, finally, we can start Visual Studio again, and the extension should be installed. There are quite a few useful extensions, not just the most obvious ones like child process debugging, the one that's needed for Qt. So you might want to take a look through this extension browser. There's also a website for it on Microsoft somewhere, where you can see if there is anything you might want for your workflow to improve on that. The extension here is fine. It is to be found here under Other Debug Target, Child Process Debug Settings, and we just enable it and save the setting, and now it will apply to all the processes. In principle, here we could define a list by process name or also by command line, including I think wildcard support, if we would not want to connect to all children but just specific ones, which in some use cases is helpful. So the way this works here is that it hooks some of the process creation functions inside the spawned processes, and this hooks then notified Visual Studio to connect if a child process is being created. So it's a bit a convoluted way of doing it. And the downside is that, of course, if you are hooking some functions, for some reasons, if you would also want to hook some of the functions yourself, then these hooks might interfere, so it might be useful to be able to disable it for selected processes. Also, an important notice, this setting is per project. So if you create a new Visual Studio project, then this will be again reset to nothing. So for every project you need to configure this. Yeah, so we did it. So we have here our networking thingy. So let's see on the UI. And let's just, I don't know, let's add a few buttons. Start server, start client, and a spacer, and then let's set that this should have a layout, a grid layout. In case we want more, then we'll also add a side space on the side. Let's give it here. Then we will have button on server. That is too generic. We'll have different servers, so let's call it run TCP server. Right. Actually, we might even have more than one TCP server. So run TCP server Qt. Because we might also want to create a socket and connect to it the way as you would do it on Windows. So in Qt you have, of course, abstraction for everything, which is very nice since it's then platform independent. For Linux and for Mac it will come with different abstraction sets, so that what you do will be properly translated to the native calls. But if you would want to do it manually, or would want to create an application which is not Qt based because you want something really lightweight, then of course it's good for you to know how to do such things with the means that are offered by Windows, respectively by at least somewhat generic libraries. So some of the functions available for sockets are so generic that they would also compile on Linux. The newer ones not, but the very old subset yes. So here we will be creating a TCP server using Qt method, and then for comparison also one using the native Windows methods. So here we will just call it the same server. Yes. Let's put Qt in brackets. We don't need to really call it run. It will just, because it always will be run, I guess. Let's leave it. Right, and now we just copy the thing, but it's not the name. That will be just the client. Run TCP client. zack. Let's copy the name again. Zack, zack. And then let's add a few more buttons, which will be populating later with functions. This one will do more or less same thing. UDP node or peer, but we need two of them, so node 1 Qt and node 2 Qt. Run UDP node 1 in brackets Qt, run node UDP node 2 brackets Qt, and of course we then copy the name here as well. Good, that should be enough for now. We will be starting at the top and then continue as time permits with the other examples. So let's save this thing as well. Let's run it to see if everything is fine. Then I also will have to enable the network module for Qt. So currently, as you might remember, we just created the project and used it, but since Qt is so big, there are things which can be enabled or disabled. So if you go to the Qt project settings, you have to here Qt modules, select modules, and you have a huge list of all the different things which we have installed. And in the graphical application, by default, we have just core, GUI, and widgets. And like GUI is the basic layer to be able to draw anything on the screen, while widgets are the actual Windows-like widget. If you would have a Qt Quick application, we would use QtQML, Qt Quick instead of Qt widgets. Of course, we can also mix it if you want. Here's the Qt serial port, which you might use to talk to an Arduino or any other hardware in your lab. But since here we are in a VM, we won't probably use it, although we could spawn up a second VM and make them talk to each other through virtual serial ports. But I think this will be an overkill. So as said, we wanted networking, which is here, Qt networking. Network authorization is something different, we don't need it. Some of the things also wouldn't really work on the desktop, like Qt NFC. Usually your computer doesn't have an NFC reader. Some laptops do, or rather even some tablets might, but even laptops is more than unlikely. So Qt is in principle also intended that you could compile an application and dispatch it to a phone, which would of course usually have NFC and stuff like that. But then of course you should at least, you don't have to, but you should at least optimize the UI for phone use. So using a desktop UI on a phone is kind of not great, let's say. Right. So we added here the netted thingy. We should also add this to the release build. That it was a small oversight. We could have selected here all, and then we could set it for all. That would be more convenient, but well. Okay, so we did this. We check again if it still runs. In principle, it should. So there are just a few new include directories added. Okay, as we see, it does. So let's start with adding some functions to our thing. So slots, public, private slots, run TCP server Qt, TCP client Qt, run UDP node, node 1 and node 2. We could of course improve this later on to save on complexity, but for now let's go with a very straightforward approach that we can improve on later. Such building up approach is usually more pedagogical than just diving into the complex things from the get-go. Alright, and we of course need to add here the class name prefix. Connect. What was it? UI.btn TCP server, signal. Or let's do it the new way. AQ. push button. Is the triggered? No, pressed. What else do we have? Pressed, released, clicked. Clicked is better. Because pressed is when it goes down before it's released. And clicked is like when the action was fully taken. So let's go with clicked. This, comma, networking. Actually, it might work without the prefix. And this needs here this prefix. And this will need this prefix. Right. So, and just see whether it compiles. But as you see, it is kind of... it's not happy. Do we need to provide the full name? We need to provide the full name. Zack, 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 zack. Yeah, even if we need to provide the full class name, although we are already in this class, this is kind of more convenient than the old signal and slots mechanism where you wrote the function names in brackets and then also had to provide the argument list. So here, not having to provide the argument list saves us on typing, and especially it saves us on potential mistakes, because if you misformat the argument list, then it will compile, but the connection will not be made. You will get only an error message in the log, which you might not see, not notice rather, and then your application, you press the button and nothing happens. That's usually a bit annoying. So this approach here is validated during compile time, so it's much more reliable. Of course, this is a type of job where using AI would be great, because usually after making the first two lines, the AI is at least smart enough such that it is able to pick up on what would be the next line. And help you complete it, so it saves on time. But I would not trust any more complex tasks, so I tried it on and off for, well, since it pretty much came up, and the result is simple, extremely trivial things it can do. Some more complex self-contained tasks as well, but everything that has a non-trivial complexity, it usually fails, at least with C++. People that are using, I think, Python and some more other languages seem to have better results. I guess it also depends on the amount of samples available, and usually for Python you have like the most training material, and usually also people that use Python won't have very complex demands, so their perception of the quality of the AI will probably be a bit better than for a C++ developer. But it's a great time saver, especially with such annoying simple like here connecting slots, or if you create some API and then just fill in things. If you already have defined a list of valid messages and have function names which are somewhat corresponding, then this is typically a job just for pattern recognition and completion, which such mechanisms can do quite good. Okay, so what we will want to do here when we run a server, we actually want to start we could just actually do it in two ways. We could, of course, start it just as a local thread and then just have threads talk to each other. But we want this to be really like an example of an inter-process communication. So we'll be actually starting a new process. And here again, we would have two approaches for the new process, how we could pursue this. One option is that we create a new project here for any and every operation we want. So we would have like networking exe, networking TCP server exe, networking TCP client exe, networking UDP node 1 exe, and so on and so on. Sounds a bit overcomplicated. So what we will do instead is we will create different instances of our current application, and then this way we will be able to just by providing different command line arguments, make it do different things. So if you started without any command line arguments like the debugger does, although that we could also change. So in the debug settings, you can specify the command line argument you want, but we'll leave it as empty. And we'll make it such that we here will just spawn another instance of ourselves, but with a command line argument, for example, dash TCP underscore server underscore Qt or something like that, to be determined soon. And then we will be, of course, through the extension which we have installed, automatically connecting to this other instance, and we'll be able to see what's happening. It would be in some way nice if the other instance would be a console application, so we might also look into how one could open a console if it's not a console window. So on Windows, unfortunately, it's a bit convoluted. So when we click on networking properties again, and then go to Linker system, then here we have subsystem, and we here have selected Windows, which is basically a graphical Windows application. Console would be a console Windows application like CMDX or the other examples you have seen in the exercises or and so on. And as you see, there are quite a few other options. So native is a special case of a console application. Native in this case means it only uses functions provided by the NT subsystem, and it doesn't need the Win32 portion. So Windows, when it was created, started as a 16-bit application, so it was very primitive at the beginning. Then with the Windows 9X line, they moved slowly towards 32-bit, but Windows 98, 95 and Millennium were not truly 32-bit operating system. There was some sort of very weird hybrid between a 16 and a 32-bit system, and parallel to this, Microsoft developed the NT kernel, which started its life as NT3. I think 3.0, 3.5 was then already a bit more mature, 3.4 was usable, and 3.5 was basically Windows 2000. And then from there on, all the other Windowses are based on this lineage, so Windows XP, Vista 7, 8, 10, 11, etc., all based on the NT kernel. And the thing about the NT kernel is that it, since it was a new development, they kind of got rid of many legacy stuff, so to say, that one had in the normal Win32 system. So, for example, in normal Windows, you always have drive letters, but the NT subsystem doesn't use drive letters, it uses device paths. The annoying thing is those are not static, so when you reboot with different drives connected, the naming will change. There are mechanisms how to resolve those, but it's not so straightforward. And if you want to create an application which can run at the very early stage of Windows initialization, for example, like the checkdisk application that you see when you unplug your PC without shutting it down properly sometimes, that would be an example of such a native application, because it will run and it will do this before the graphical subsystem will be initialized. So this is the native thing, and then we have a lot of different IFI things. So for a computer firmware, if you want, if you are developing firmware images or just want some EFI tool that you can run on a computer without an operating system, that, for example, would be the AFI application here. But those are for us not relevant, and POSIX is something very, very old, so we won't care about that either. But the general thing to take away here is that if you have selected this Windows option, then if the application starts, it will not create a console, and you won't be able to write to the console. But there are commands which you could, APIs which you can call to create a console nonetheless, and then write things to it. So it might be something that we might want to try. Or another option would be, of course, that we create just one additional project here, which would be by default a console application for all these things that we want the different servers and clients here to do. But for now, I think that would be overkill, so we can later on change it just by moving some files around. And one more thing to be noted here is that if you would go the other way around, you would create a console application. From it, you can, without any issues, start Windows, open Windows, and so on. So this is really more a restriction in one side. And this might sound peculiar, but that's how Windows has implemented these mechanisms. Right, so we will first of all need to find out what's the name of our own application. So, of course, when we build it, it will be, and also when it's loaded, it will be set here, but that would not be a good approach to just take this value, because on your systems, this path will be different, since it contains, in this case, even the username. So that's, of course, not a viable solution. So what we want to do is we will first create a variable qstring my path, or my exit path, and then we will just resolve the name on runtime, let's say here, Q application should have application file path. That might already be it. I'm just not sure if it is the whole path or just with the exe name. Yeah, it's a complete path. You notice that it uses forward slashes like on Linux. This is something with Qt that might be a bit annoying, that even if you run it on Windows internally, it will use the forward slashes. Although if you feed it backward slashes, it will process them the same way. So it doesn't care which you do, but it always gives you the Linux notation. And I guess it's also not guaranteed that using backslashes will always work out correctly. So if you would interact with the Windows API, you always need to take into account that you should, first of all, if you are feeding strings to Windows API, always convert forward slashes into backslashes. And the other option is that if you feed Windows paths to Qt, you might want to be diligent and replace the backslashes with forward slashes, but you don't have to. Qt should process this correctly. But of course, if you would then want to pass paths and do things like that, it would be a huge hindrance if you have mixed slashes, because then you always need to look for both when you're traversing a path and so on. So it is good practice to just settle on one convention, and since Qt, whenever it generates a path, always defaults to the forward slash, then if you are writing a Qt application, just do the same. And if you want, then only convert to backslashes for for display, and when you read back from a text editor, so well, then convert it back to the forward slashes. So here we have our path, and let's start the server. Although before we start the server, we of course need to have means to differentiate. So we go back to our main, and we have here initialized Q application with the argc and argv. This is the argument count, that is of all the arguments that have been passed to the process. So if we look in the task manager, let's just sort this by start time on something started. Then you have here, that's a bit too much. For example, here, then you have quite a few commands, and each entry, each argument is either separated by spaces, or if you want an argument that contains spaces, like for example the file path here, then you need to put it in apostrophes. Then the whole thing will be taken as one argument, and the count of these arguments. So if we, for example, take this as an example, we have Notepad. So one interesting thing is that on Windows you get the path of the application usually as the first argument, like here, but this is not guaranteed. So if you start a program from the console, then you might end up just with a relative name, or even just a name without the exe. So just taking the first argument is not a reliable way to get your own path. On Windows, there are special API calls that you are using if you want to know exactly what's your image file name, and Qt internally uses those and does not rely on the first argument. So here I have now separated it in arguments as usual. You separate by space, except if you have something in a parenthesis. What's the English word for that? In quotation marks. And this separation Qt does for us automatically. So it, or rather technically already, the separation is done by Windows. Here we get the count of the arguments. Here we get a pointer to a array of pointers, where each pointer points to one argument. And Qt takes those and exposes them to us in a nicer form as arguments. And if I recall correctly, it's I think disposes of the first one, q string list test or args. Let's quickly test that. And having this as a string list, so here in this case, no, it leaves the one, it doesn't remove it, it keeps it. Okay, so you have here the list of all the arguments, and since it's a string list, you can easily search in it using Qt functions. That is more convenient than having to work with an array of pointers. So our approach here would be twofold. Either we really search for the argument, or we do it such that we want to just check whether it exists at a given position if this position is available. But I think looking for it is more convenient. So let's say int position arguments punct index of on server dash run server run TCP server run TCP server Qt. Let's make this for an argument. And if it is found, then pos is not -1. If it's not found, then it's -1. So if this is not -1, then we will have else. But then we need to look for the other ones. We can make this a little bit more hacky, because this way we have the assignment to pos inside the bracket, so it does the assignment, and then the result of the assignment is the value of pos, which is compared to -1. And now we can, without having like else, because otherwise we would need else and so on and so on with our own pos each time, which would be annoying. But this time, with this trick, we can just do it like this. And then inside each of the cases, if we enter them, we will have the found position available for us. TCP end Qt and UDP node UDP node, and here we have one too much because the two nodes will be mostly equivalent, just they will have a different port. So int port is equals argument punct we can use either at, or we can use the brackets. Let's go with at. At pos +1. So we assume that start server, and then the next argument is the port. Another option which we also could use, which might be even nicer, would be first to look to add like a second argument which contains just the port number. That we could do as well. Okay, let's maybe do it. So pos is equals index of dash port, and if this is not and if this is not -1, then we have a port. So if this is not -1, then we have a port, and we will have q u short port equals 0 und 16. Yeah. Then q host that we need to include q abstract socket. Is this abstract enough? Yeah. So if it's complaining it's incomplete, then let's directly include this. So if we have a port, then we know that the next argument is port, though we need to check whether it exists. So end argument punct count is greater than pos +1, else we would run into a invalid index if someone would write port but not provided. Okay, so we take arg punct at e +1 dot to int, and then we just repeat the process. Alright, and we can of course, as I mentioned, use this trick here as well. So we just have the pos so that we keep the position, and then alright, and it's called pos, not e. That was the small oversight. Zack, and here we go with IP. Actually, we could just call this IP. Let's keep it by address. Address, and this of course is different. Host address from the string will convert it from the string. So here we have then our different cases, and well, else. So if none of those is true, then we just start the window graphically, and else we just return 0 here. Okay, so here let's add a breakpoint and a return to -1 at the breakpoint, just to test whether it will be working correctly. We have pos, we have addresses which we will need later, we have our args, we have yeah, nice enough. Often when you are writing big applications, it's customary to put all this argument passing logic into an own function, but for our case, we will not bother. Our application won't be that big for this to make sense. So, oops, they click this. I wanted to click that. Right, so we are here in start server. So we'll be again including something. Hash include queue process. There are two ways of including things. So you can use this with directly the header, or they also include files which are named like this on disk. And my feeling is Qt by now would like to switch to the other approach, but at the beginning they started with this, and a lot of people likes this. So me too. So let's just stick with that. So a queue process is an object that Qt offers, which allows you to start a process and to a limited extent control what this started process is doing. So this means you can terminate it, you can suspend or resume it, I think. I'm not sure if we even can change things like priority. That might already require platform specific calls, but the very basics, like wait for it for terminate, kill it, also read and write to its console if it has any, those things you can do with the queue process. And generally you can use this queue process in two ways. You can use it just to start something and don't care about what it's doing more further. Or what you also can do is you can start it and keep a reference, and then as said, see whether it's still running and stuff like that. So either you run it standalone or not. Here for now, let's just use it in standalone mode, but we can later on change this if we want to. So queue process start detached. So this is pretty much a static function which just allows us to just start a process without any additional complications. Yeah. So when we go back, start detached just takes the path of the process, obviously. So program, that will be this is my exit path, and then it takes a queue string list of arguments. So queue string list args semicolon arguments, and then you can provide also a working directory, which in this case we will not do, because then it will just select the directory it's currently in. And you can also use this PID parameter to get the process ID out under which ID your current process has been created. Currently we will not be caring for this either, and of course we also have the return value, which just tells us if the process was created or the process was not created. This does not really check whether the process crashed or something. On creation, it just basically checks whether the path exists and the file is a valid Windows executable, or Linux or Mac or whatever platform you are on. So as soon as the create process call to the operating system succeeds before the process ever did anything, this function will already return and say true or false. And if the process then crashes instantly, then it will still say true, because it doesn't care about that in detail. So here we will just add, or can also use this semantics argument. So we said, let's just copy it so that we are certain we have the right thing. And then of course maybe we want also a port, specify port where the server should listen, and then the next argument will be the port itself. So let's say 1234. It's a nice dummy port, usually nothing listens on it. Of course it will not do much currently, but the only basically what we want is to, once we press it, to end up in this breakpoint in a second process and be able to see in our task manager that 2 instances of the process have been created. Something went wrong here when copying. We of course want to assign pause, otherwise the thing will not be valid. So here of course we first enter the case where we already are. So this is our primary instance. is it here? Networking. We might want to add to it some nice icon later on. And then just run TCP server, and voila, we ended up here. When we look at the task manager, now we see a second instance of networking exe. And of course, this one will just instantly terminate since we didn't give it anything to do. So this already works. The same thing will be with start client. So here, let's just add another breakpoint, fill in the next function. Zack, zack, TCP client. And we should specify a address. We said we call it IP, the argument, I think, yeah. 127.0.0.1. So in the old style IPv4 networking, every address that starts with 127 dot is representative of the current computer. Obviously a huge waste of addresses, since we are wasting like 24 million addresses here, which could have been put to a better use, but that's how it was defined, and there is not really a way to change it. And of course the first address in this range is the .1, but any address here will just direct the traffic back to our own system. With servers, when you are opening a socket, you usually don't specify the IP address because you want the server to accept traffic from any network adapter you have on the system, or you might not know your own IP address. If you would create a socket, a listening socket with the local host IP address, and of course it will only react to local requests, which might be what you want, but if you want real networking, of course will not be. While with clients, you always need to tell it to what it should connect to. The server can just listen on everything. A client cannot just connect to everything. That would be irrational. So you always need to do it. And while we could of course have hard coded the local host address if none is provided, let's rather go with always having to specify it, which also means that here we could add if port is 0 some error message. So if port is 0, if address is not valid. Actually, we also need port. Port must be also specified. Port must be specified also here. Then QMS. We need to include that. Q message box. Critical. Null. Title. We cannot use ter because we are not in a queue object. We could, although, piggyback on the networking ter implementation for translation, even though we won't be ever translating this, I guess. But it's always alright. And for title, actually, what I often do for the title itself, I just hardcode the name Qt networking test. Simply because this is something that should not be translated. Usually you don't intend to translate names of applications, just the text. So in this case, server port is missing, comma, and then we could specify here a few more things, but we just want an error message, and then of course return error1, for example. Then we copy this client port. Oh, well, technically it's also the server port because we are connecting to a server port. Let's call it server or IP. And this will be here if address oops, it was just ADR is null. So if it's null, then the thing here will also throw an error. Otherwise, we continue here to our not yet completed code. Right, so for the server, we already said this as well for the thing. Okay, that all looks good enough. So now what we need is to actually create such a server. So we will, in our project here, add a new folder. Actually, add a few folders. One thing about folders here is that technically they are just view filters. So the way you have all those folders arranged on the hard disk, so for example now we have GUI and networking, but here in our application we don't have a GUI folder. The whole stuff just lies on the root level. And unfortunately, this is kind of customary how C++ structures its own projects. You can, of course, by hand create folders and move files around and then correct this here. But this is a bit annoying, and usually, since you already have this filter, it should be good enough. Also, I think there is somewhere a switch to... nope. This? Yeah. If you switch this, then you get the actual file layout on this. Then you could actually here create... Oops, I misclicked. Create an actual folder. Let's call it TCP server Qt. And as you see here, now we have the folder. So now we can create things inside that. Add for example, a class CTCP Qt server. Or server Qt. We always use server Qt, so let's stick to this nomenclature. I don't like the prefix C in the name. And as a base class, we can use QTCP server. Or we could also use just QTCP object and then have server as a member. So both approaches are valid. We could also go with a completely different approach to use a QThread and then run the server within that thread. But since here we have just already created separate processes, we don't need to add here additional threads. I think the most convenient approach for us will be to just use a Q object, because this can easily later be switched to a Q thread, since the QTCP server will already be a child object, a member object. I mean, okay, Q object. This is fine. This is it. Okay. Okay, it created it not where we want it, but we should be able to move it where we want it. Zack, voila. But if we switch now to the other view, then those again are unsorted. So it's more or less up to us how we prefer to sort them, either with this view filters or with really folders on disk. The downside with folders on disk is that then if we want to refer to those things, we need to include the folder name, so it doesn't automatically searches in all the subfolders here. So it is more convenient to just have a virtual ordering instead of a real one. But here for our purpose, for this application, let's go with the real ordering. So we'll be doing things like this. Okay, so we have our thing here. It was a bit creative about how to include QObject. Including the whole path is definitely the worst possible option. QObject, public. And before we start this, actually we could already add the constructor to it. Object stamp. Oops, null. TR. We'll go here and we'll here there. We'll of course need to create to start the thing somehow. So what we also could do is we will be just adding this start statement to each of those scopes. Because what we want is for this thing, so which we define here, to stay valid until this thing finishes. If we would have the return here and we would exit the scope, then everything inside the scope we would need to create on the heap, which we also could do. But I don't think that, well, maybe we could do it. But let's for now just go with this approach. So here we need to include our new hash include TCP server Qt, TCP server Qt, and then we just create it on the stack, TCP server Qt, and we don't need to make it anything, just server, and we could start it, or whatever function we want to give it. We could also start directly from the server. We then maybe add a few more arguments like the IP and address if set. So we'll make a second constructor which already takes those two arguments. Q int 16 port Q host address. We will need to include that here so that we have it. Small q go with address and then parent, and this thing we already make optional because for the server it is optional. So we need our two constructors. Of course, no default arguments in the implementation. And the way we can now do this is, this one has q object parent, and in this one we can refer to the previous one. Oops, is that correct? We can refer to the previous one with the arguments it can consume, so we don't need to replicate code if we would, if this would be a more complex thing. But it isn't, so for now it's fine. Q TCP server. Oops. This will make a member variable TCP server, or just server. To call it a listening socket, but let's go with server. This will be automatically created, and here we can listen to a address. In this case it's any, which should be equivalent to an empty address, but we can for good measure initialize this correctly. Host address any okay, right here, and then of course we have the port. What can we also give it? This one's arguments. No, that's all. So at this point it will open a listening socket and start listening for incoming connections. So we need to connect a slot of parent server, comma q TCP server pending connections. Which one was it? Let's just see what it offers. Signals. New connection, that's the correct name. Yeah. New connection, comma this. Hands on connection. Then we need to add this, of course. TCP server. Void on connection. So when a connection attempt happens, a new socket will be created, and we will be able to retrieve it from our server in this function. Let's put a breakpoint here, but not too much more. So in principle, when we run this, we should be able then to observe in our task manager that it's opening a listening port on the port we wanted to open on TCP server. The firewall is asking whether I want to allow it. We allow it. This breakpoint we don't longer need. And here on our second instance sockets, we have it listening. So 000 is like any IPv4 address, and dot dot is any IPv6 address. So by default Qt will open sockets which listens on both. So basically internally two sockets, although Windows allows you also to create one socket that listens to both, and thus internally you have like one object referring to a universal socket, while here in the task manager you will see for IPv4 and IPv6 separate entries, but they might refer to the same internal socket object within your Windows application. And of course, if we terminate this, this closes. If you really terminate it, it closes all the instances that it connected to. So our one here and the other one there. So both get killed. Good. So we have our server, which is not yet doing much, but we already have something. So let's create now some client that we can start to trying to connect. So add folder TCP and Qt, and we'll add again. Or let's be more efficient. Let's just copy this to there and rename it, and we will already have at least something, and we will be able to save on typing, and then we can just drag and drop it here, and it's fine. Alright, of course here we need to change server with client everywhere. Page zack, H server with client zack. Right, we just need to make the right. So there is no TCP client on Qt, there is the TCP socket. Then here we will of course need to call this a TCP socket. Oh, we can also keep the name at client. This here can stay as is. This constructor will auto-connect. Of course, there is no on connection slot. There will be other slots, but not this one. Right here, so client connect to host address port and mode read write, which is what we want. So we want to be able to send and receive data. This of course doesn't exist. Zack, zack. Before we add anything else, to be actually able to transfer data, let's just check whether the connection establishment itself works correctly. TCP client, and let's call it a client. And it's complaining because it's not yet included, so it doesn't know the type. We need to duplicate this. Client, client. Now it's happy. We can also remove this breakpoint. We don't really care, because what we want is we start the server, we start the client, and then we should end up in the server's new connection event loop. Also, the Windows Firewall will not be asking us for the client. It only asks for when something opens a socket so that it can accept connections. It doesn't ask for outgoing connections. So our server is already running. We can check this here. It probably would be good to have here a list of things that are running. We'll add that maybe later, and then we run TCP client. We can remove this breakpoint, and voila, we are here in on connection, and we see we have two network things. We have two listening sockets as before, plus one established connection between localhost and localhost, and local port 1234, and remote port something random. And the way it works when you are connecting a TCP socket to a server, every connection needs to have an IP on both ends and a port on both ends. Otherwise, the operating system or the network itself wouldn't know what to do. The network itself cares only for the IP, not for the ports. Although if you have network address translation with a net router, that's again a different story. But just on the internet level, or any networks without net routing, then all the hardware only cares for the addresses, and the port is only something relevant for the operating system to know to which application the communication to direct. And when you are hence when you are connecting to a TCP server, your operating system locally will pick a random port, and your connection will use this port as an outgoing port. You could specify the port you wanted to use, but there usually is not really much utility in doing so. So yeah, so that's why this is random. And of course the other one has only the one established connection from its port to the remote port, which is now the one specified on the server side. Okay, so as you see, it works. So now we will want to send some data. So let's go again to the client. And after we have connected, we can either just queue some data to be sent in hope of a connection being successfully established, or we can be a little bit more correct about it and wait for the connection to actually be established before we start sending data. So let's quickly see what our client has to offer in terms of signals. So we see this is from abstract socket derived, and it doesn't have almost anything. So let's just see what abstract socket offers. Signals, and we have a connected and a disconnected. The funny thing is, for UDP you don't have connections, but UDP socket will still be derived from the abstract socket. So in principle they could have put those signals directly on the TCP socket, but they didn't, and most other types of sockets will be connection oriented, so well, good enough. So let's add here our TCP socket with and of course this is the client on connected. We just need, of course, a unconnected slot, or on connection, unconnected. Well, the names don't matter, they just need to be consistent. And since we only have one client, then it's easy, we just write hello. So once the connection is established, we'll send hello and new line character, and then on the other side we will want to receive it. So now we need to look in our server. Plus, if we want then bidirectional communication, we will add things, more things. But well, actually here we could actually maybe let's go step by step. So on the server side we have the socket, and as we have said, on connection will receive the connection, and the connection will give us an own TCP socket instance. So basically the way it works is you have a socket which is listening at it, and it then can generate new socket instances for every incoming connection, so that when you are replying and communicating with the other clients, you can refer to each of them with an own handle instead of somehow having to use their addresses or stuff like that. So a server might be implemented such that it is not even actually aware of the address of the communicating party. There are of course functions which you can call to retrieve the address from a socket, but you don't have to do it when you're using TCP connections on the server side. So since we might have more than one client, we should make a list of clients, qmap, or maybe even a better map, qtcp socket. I'm not sure if this is now included or not. It will complain early enough, and this should be a pointer, because we will get a pointer from the server, and then we can associate some client data with this socket. So struct as client data we probably want, it's reasonable to do so. And here again we could either put it as pointer or not, but let's go with just the client data and call this am clients or sockets. Let's keep it consistent. So if this is called client, then this will be called clients. Right, and the client data would like to have something. Let's just retrieve the port and the port and the address. Okay, so we are here. So qtcp socket, then next server punkt next pending connection should give us a TCP socket pointer. Yep, and it does. We could also first of all, let's put a breakpoint here, and then let's check if this thing has a parent set. Q asterisk. It will be it. Is it a typo? The thing is, I think either the IntelliSense is not up to date or it's incomplete. So we need to include this here as well. Otherwise it won't know what to do with it. Right, so let's run it. Start the server, start the client, and we see that the parent is set to something. So we can check what this parent is. Next should be of type socket, not server. Right, P and so the server sets itself as the parent for this object, which kind of makes sense. If we dispose of the server, I would like the child object to go away as well. So here we will assign maybe, however, ourselves as the parent. Well, for now it doesn't matter. If you would want to use a smart pointer in the list, then it would be important to clear the parent here so that we don't get a double free. Actually, let's do that. That will be a nice demonstration of other approaches to PTR. A nice demonstration of other approaches to memory management. Q shared pointer. Q shared pointer from socket. And this is a reference counted shared pointer, which is really nice to work with. So clients punct insert, or we could also go with such an approach. Yeah, let's go with insert. But it will not take pnex. It only wants to know more details about the thing. No, that complicates things too much. We can try this somewhere else. Here, let's just go without setting this to null, just with the pointer. This will be more convenient. You will see in a moment why. And here we just enter this data, which we need to populate first. So client punct not clients next punct peer port should be the remote one, I think. Punct port is equals, we will see once we try it out. Data punct address, so let's click with next peer address. Okay, so and this will make like this. I prefer this notation. It works the exact same way, but I find it's nicer. Good. So we will be able now to track of our connected client, and the next thing we want to be able to receive data from that client. So again, we see what our TCP socket has to offer. We go to abstract socket. Here we actually will not find much. Where was it? Here we only have like connection-oriented stuff. We don't have really much signals that would be related to data being available. So we see this is derived from QIO device, which then, as you see here, is derived from either QObject or this base, depending on how you configure your Qt build. The default is of course that it's QObject derived, and then we go to the signals, and we have here a signal ready read, which means this will be fired when there are some data available, so that we can read from the object. So we will need to connect it. Connect, And now what we could have done is we could have instead of creating just a struct to keep a few data, we could have created a whole own client object in which we would then be handling this user's requests. That would be a more advanced approach, but since we have rather simple things we want to do here, we will be going with the approach of keeping everything contained to the server class and just having a helper client structure. So we'll be connecting the socket at ready read, we said it's called, with this, and we'll have a second on we could call it on ready read or on data or however. Let's stick to this naming scheme. So on ready read, then we of course need to create this thing, otherwise we cannot use it. On connection on ready read. Actually, I don't like it. Let's call it on client data. Yeah, I like this much more. Let's go with on client data. It's kind of, it helps you to keep track what is connected to what if you just have something and then on this thing, but some things just sound ugly. So, oops. So, let's go on client data. So this will be triggered once our client tries to send some data. We could of course put also a breakpoint here, but we assume this thing will work as promised. So let's just see if we end up in the other breakpoint on our ready read slot, and voila, we ended up here. So as you see, everything still works as expected. Now, since we have not created an own QObject based client object, because if we would have done, then it would be an own object with an own slot, and it would already have only all its own data available to do whatever you want to do. But since we kind of wanted to integrate it into the server, inside the slot, for every client will receive the same notification. So we need to be able to somehow tell the clients apart, and we can do this by using our a function called sender per socket. We will maybe change this here from next to just socket because I like this more. Let's go with socket is equals sender, and this of course doesn't like it because we need to cast it, because sender just gives us a QObject. So we could either just hard cast it knowing that we are doing the right thing, or if we are not sure, we could use QObject cast not dust cast, and this is a safe version. So this QObject cast is a template function which here implements this meta object cast at some point. Can we even jump to it? We cannot jump to it. It's too abstracted for the intelligence to be able to jump us to it. But the way this works is that if the sender would not be of type that is compatible with QTCP socket, so either QTCP socket or something derived from it, the result of the operation would be null. So we are here safe. We just check if not this, then return. Or we can even use a different check. List. That could have been played better. Let's improve this slightly. I remember our shared pointer. Let's use it here for our data. That is much more elegant. P data is equals. Is there any? There should be a new instance create. Yeah. Okay. This is much nicer. It's more modern, at least, and well, modern is not always better, but it's good enough. So pdata is equals client. Then we use the function value at socket. The function value on a map gives us the value held for the key. The key is whatever you specify as argument, and if it doesn't find anything, then it returns a defaultly constructed object. So here we always go with an assignment by value, not by reference. And if the element doesn't exist, it will, in this case, give us an empty pointer. So here we just check if not this, then return. And in principle, we could of course check if socket is null, but since we will never add a null socket to the list, this is good enough. And performance-wise, if we assume that we will never run into this thing miscasting anyways, it's fine to just have one safety test where it really matters and not add additional tests which will usually just be passed. There are of course other options how to get a value from a map, like this square bracket operator. But what this does is it either returns us the object, but if the object doesn't exist, it will create one and insert it into the map and give us the reference to that object, which of course we would not want if we want to check if the map contains something. So the value here is a much more convenient thing. And if you think about what you could do using the standard template library, there you can use the square bracket operator, but it does not have a function like value. There you have to use the find function, which would give you an iterator, which you can test whether it's valid and then fail, or extract the value of your object from that iterator. So it's a bit more convoluted, and if you want to write nice and readable code, Qt is somewhat significantly nicer than the STL way of using objects. Maybe they will improve that at some point, but currently I am not aware of much improvements on this field. So when we are here now, we have our socket and we have our data. For the data we kind of don't care right now, but from the socket we can read all. How read and read all works I have already explained when we did the very simple text editor, when we took a look on the Qt UI. So I won't explain it again. Just read all gives us everything that can be read at this point from that socket, and if more data arrives, on client data will just be called again. So Q array, we should not call it data if this is data, buffer. And we'll keep the breakpoint here, we will run it, and once we arrive here, we should see our hello in the buffer. And it is there. Nice. So, things to remember when using network communication. Currently we are using TCP, which is a stream-based protocol, and this means you really have just a stream of data. You pour in things on one end of the pipe and it's getting out on the other end. There is no mechanism built into this protocol to packetize the data. So here we are lucky, or it's to be expected that we get hello in one go. But if we would be sending it not locally just through the loopback adapter, but somewhere through a satellite connection and have modem connection, some other connections, we might have just received HL, HA, and then another package which just says ELO, or any other way how the message could have been broken up in transmission and then reassembled on our end. The only guarantee that we get from the TCP protocol is that the data that arrive will arrive in the order in which they have been sent. They cannot arrive out of order, and that the data will either arrive or the connection will break. So if we would get some of the data, then some portion is missing, then we get some more data. The operating system will not give us read access, will not trigger in this case the on-client data event as long as this block of data is missing. We only get read notifications for however much data has been has arrived in and is complete. And then if this missing piece never arrives, at some point the system will just trigger a timeout and tell us the connection broke. And that's it. Even if some additional data would be there, but if we don't know where they belong, we cannot really use them for anything. Other protocols like UDP, which are message based, are different, but this we will take a look once we try that out. Here it is just important to know that when you are reading data from a stream device, you cannot rely on one message being one read. You can have the message being broken into multiple reads, or you can get one read with multiple messages just attached to each other end to end without any separation. So it is up to you to format your communication such that you can make sense out of it without knowing how it was put onto the sending socket. In this case, for example, since we sent hello with a \n, so with a new line, with a line feed character, we could use this as a indication. So for example, we could structure a protocol that we want data until a new line character, and we only process them once we have received the new line character. If we have not received the new line character, this would mean that some data are missing. And the same behavior, the exact same behavior you will get with the serial port, for example. When you're reading data from a device on your attached to your computer from Arduino or something much more expensive in a lab, you just get a stream of data, and you have no guarantees that there won't be like pauses, gaps, breaks and stuff. The device might like send something, then start thinking. You already can read this, what it sent, and then it sends some more, then it thinks some more, then it sends some more, then maybe it might need to perform some physical operation, move something, and then just tell you, okay, I moved to this position, etc. So you will have to handle such streams. And this data object, which we have created here, by the way, we have not checked whether port is correct. Let's quickly take a look on that. Is something we can use to help us with that. So hex, let's see, data, value. Okay, so this is the wrong one. Peer port is the, no, sorry, it's the right one. It's the right, because we are on the server side, so we receive the random port, so this is fine. But anyhow, returning to our data stream problem, the best approach here is to, well, the only approach really is to create a buffer. And since you might get different data chunks from different clients in different order, you need one buffer per client. So here we will add a queue with a byte array, capital B, and we just will call it buffer. And here in our read operation, we'll just buffer plus equals, it's an error, and this means we'll always concatenate everything that comes into our buffer, and then we can process it, look for a package header, look for the size. So another approach, if you don't want to use the line feed characters or something like that, a much more advanced approach, let's say, would be to have like a binary format of your data, so that you have some header, some numbers that identifies the package, maybe some opcode that tells what the package does, then some length field which tells how much additional data are attached to this package, and so on and so on. But for now, here we will go with the simplest approach, with just a text-based protocol. So we will be just using the line feed as the indication that the data is complete. So int pos is equals buffer index of \n, and then we just check if this is, so if this is unequals -1, then it means we have at least one line of data, but we might have more. So technically this should be a loop, an infinite loop, and if this is null, then our loop should just break, and if not, then we have something. So we will just call it line, since that kind of naturally makes sense. Punkt left. Left gives us the amount of characters specified in its argument from the left side of the string, so from its beginning. And since we have this data now in line, and we don't want to process them again, we want to remove them from buffer. So remove 0, that's the starting offset, and the count will be position. But position will remove everything except this \n. We don't want that, so we add +1. Oops, here. So that we also remove the \n, and we want here, of course, to add hello, hello, hello. We'll just send a few hellos. They might in fact arrive in one go, we will see. So we have removed them, we have our line, and from now on we can just process our line. In the simplest case, let's add a helpful include, although I should really add that into the... actually, we should make all the includes here, that would be much more convenient. Zack. There will be a lot of duplicated includes, but we will fix that manually. Network, for network we don't care, but process we want to have here as well. Okay, so it is quite smart. It shows us in gray which ones are redundant. So we have all the includes here. Yeah, and I wanted to include qdebug, which allows us to write to the debug console here or to the normal console if the other one is not present, any text we want. So in server, here we just add qdebug brackets, and then we just will write line, and this should be a little q. Okay. Right, and we put a breakpoint. Let's add one here, and we'll see if this will really arrive in one go or in multiple ones. Okay, so let's run it. This will now rebuild all the files, so it might take a second more because of the modified precompiled header. Okay, run server, one client. We are here. We make a single step, and buffer. What does buffer contains? Hello, hello, hello. As you see, although as you see, there was enough latency in the system that Windows just bunched all the messages together, even though they have been sent kinda individually with an individual write. So here it's good that we have our function we have here. Then we have our line. The line contains hello already without the carriage, without the line feed. The buffer now should only contain the next hello if we have not messed up the offsets, and it looks correct. So we can just remove the breakpoint, run it, and in our debug console here we have our 3 hellos. So as you see, this works quite nice, and we have already implemented some very rudimentary message formatting, so that we can definitely say when the message is complete. Of course, the downside of such a simple approach is that the message itself may never contain \n, because otherwise we would break on that, and that would not be correct. So we would need to add some placeholder or define some escape sequence or something. But usually when you're talking to hardware and stuff like that, you will not be sending the \n symbol in a message anyways, as long as the protocol is of course text-based, because then their implementation will do the same thing. They will just take the \n as the character on which to break and start processing the command. So of course you cannot send raw binary data through such a protocol, because some raw binary data might randomly be the byte with a value of 10. For example, if you send the int 10, then that's exactly a \n. So obviously you would need to text format your integers and stuff like that, and not send them raw through the network. Any questions so far? Okay. If there are no questions, then let's send something back. So for example, each time we receive a hello, we could send to our client a reply, or I'm listening, or what? Let's be unpolite, and \n, and 3 exclamation mark to be particularly unpolite, and the semicolon so that the format's correct. Right, so now we can adjust, copy a few things, this and this and this and that. Really, one of the few good things about the modern Windows is this nice multi-clipboard. although that isn't really such a incredible thing, because in the good old days they were just third-party tools that did the same. Right, and I copied this thing because I thought we might want the data, but in principle we just really only care for the buffer. So we just put the buffer as a member and don't have the object for this. So here, of course, we need to adapt things. There also, by the way, is a callback. Like here we get a notification, data ready to read. There is also a slot which gets triggered when all the data in the buffer has been sent, or when some data from the buffer has been sent. So in our example here, we really assume that we have much more communication bandwidth than what we want to say. In case of a COM port, this is kind of guaranteed because the write function can just lock if needed, and that's it. But with the sockets, you would not want write to be a locking function. So usually you either send as much as you have to send and hope that it will be fine, or the more reasonable approach is you send as much as you can until the buffer fills up, and then you wait in the for an event, or in this case for a signal to be fired, that there is new room in the buffer, and then you add some more, and so on. And on the other hand, what you also could do is, if you control the rate with which you are filling the buffer, you could control the rate with which you are sending data. And in fact, the way how TCP is implemented, if you control the rate with which you are emptying the read buffer, you can force the network to lose some packages if your buffers are full, and then force the congestion control algorithm of the TCP protocol to reduce the sending rate on the sender side. Usually you want to receive data as fast as possible, but if you want to implement rate limiting on the receiving end, you could do it like this. Of course, it's much more efficient to implement rate limiting on the sender side, because the sender side rate limiting is fully graceful. You just send less data and it's fine. On the receiving end, it's not, because you cause forcefully a packet loss, just some, and thus there is some amount of bandwidth wasted by such an approach. But it's really negligible. So if you want rate limit on the client side, it's fine. Right, so we are here. We of course don't need this because we only have one instance. So here we have M, and it's not M socket but client. Zack. And client was not a pointer. And of course we will not want to send something back again, because this would then just make like a ping pong forever. Beep, 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 beep. They would be just screaming at each other all the time, which we don't want. Right, yo. So we should now, when we run it, just see the hellos 3 and then the 3 watts replies in the log. If we did not forget anything, so let's just run it. Run. Yeah, hello, what. Works nice. So now what we of course want will be to be able to do something if the connection breaks. So on the client side we already have the on connected. Let's add also a on disconnected slot. On. I'm never sure how many ends the word disconnected has. Let me just quickly check it. Seems right. Good. It was pure coincidence. So we have here disconnected, and in principle, if we are disconnected, we don't really have anything to do. We will have more to do on the server side, which we'll add in a second. But here, what we could do is to add, for example, queue application post. Should I just quit? Yeah. So if the connection breaks, we post a quit message to our own application instance, and then the client process in the task manager should terminate itself. So yeah, this is this. Let's keep this in order as things should happen, although this really has no other meaning. Right, and here we have this disconnect, but this time of course with socket, and this of course on server. Then we need to copy this. Yeah, disconnected. It does not sound great for the server side. On the client disconnected, but that's too long. Socket disconnected. Wurscht. On disconnection. Let's just call it on disconnection. On connection and on disconnection. That sounds nice. Right, and since the rest of the code will be quite different either way, we just will copy and paste it here. We'll repeat this procedure. We want to know what it is, but now we will, well, technically we don't need to care for that. Basically what we want is we want to clean up the client from our clients list. So client.remove socket, and that's it. If we would want to somehow clean up something, like manually delete something or write a message incomplete data in buffer, or if there is incomplete data in buffer something, we can use the take function, which is also super convenient because it takes the value from the map, so it removes it from the map. It doesn't longer exist in the map after take has been issued, but it returns us a copy. STL again doesn't do that. You can do something similar with iterators. You can get your iterator with find, then you can get the value, then you can erase it, so you don't have redundant lookups in the map either, but you need more code for that. So Qt is really nice in that sense that it has such combined convenience functions. If you don't want to use Qt, you want to use STL, I would really recommend to just make yourself a bunch of such convenience functions which you then feed with maps. So obviously you would want to make these functions as templates so that you can feed it then with any sort of map and so on. Yeah. Right, so in this case we take it, but we don't really care for anything else. So what we could do, for example, is we could generally here print some more information, like you debug client connected. That should be of course in brackets. Client connected address .to data data address .to string. And that's annoying. So each time you have such a shift in operator, if you're using STL with cout, that just prints. In Qt, when you concatenate more of those, it will always add you a space for whatever reason. So if we want to have like a string without spaces, then we need to do it with pluses. Plus double point, oops, plus q string number port. Yeah, client connected, client disconnected, client disconnected. Right, yo. Right, so let's try it out. We currently don't have a means to close the connection actually. Did it connect? Or did it fail? They pressed the other one too fast. Yeah, we have one networking, the other one didn't do anything. Let's notice this press. Okay, so now we have here client connected, but the rest didn't print. Something's not right. Let's just restart it once more. Okay, run server. We should be debugging the server. Networking, what of status. Another thing, it might see like this. Nope. Status here. It's not being debugged. No, it is being debugged. Fine. So this is fine. It is being debugged. So is that the other one? It didn't start it. Something's not right. but we didn't really break anything. This thing is listening where it should be listening. Why doesn't the other one want to work anymore? We get the client connected, but we don't get anything else. So there must be something. Did we made a copy and paste error somewhere? Oh yes, yes, a big one. We were terminating the program as soon as it connected, because in our effort to not type too much, we forgot to update the name of the signal on which we trigger the application quit. So we broke it. Okay, click. That works, and it's still connected. And there are two ways how we can disconnect. First of all, we can just kill the process here, but this particularly advanced task manager allows us also to kill sockets of other processes. Suck. Shouldn't give us an error, but it still worked. Client disconnected. I don't think we had a logline on the other, and the other one doesn't have a logline. And we also see that the other process has terminated itself since the connection has been lost. So we can also start a few more instances. Each time it will just do this hello, what, and so on. So we can also here terminate them directly. That also works. So then we get here our 3 clients disconnect. As you see, each client picks for itself a new kind of random port. In this case, the ports are incremental, but it is not necessarily guaranteed. We also see that the IP address is a bit strange. There's this FFs at the beginning. This basically is a special notation for IPv6 addresses, where an IPv4 address is mapped onto an IPv6 namespace. And this, in our case, is needed because since we selected for the server by default address any, we could have also selected different any's. There is like any6 and any4. So we wanted our server to listen on IPv4 and IPv6 addresses, and thus the socket as such must be an IPv6 socket, and then it will just use a portion of its namespace for the IPv4 addresses. Okay, any questions so far? Okay, if there are no questions, then let's continue. Right, so we can close this, we can close that. We have sending and receiving on both ends. We have connection handling, so our servers are actually already quite nice. We could add some UI to it, or we use the remaining half an hour to create a UDP server, and well, not server, UDP node. I think that might be enough time, so let's do that. So we will again create. Should we create it from scratch? Yeah, we should create it from scratch. So the UDP thing will be sufficiently different. UDP node Qt. That will do it from scratch, and then later we will take a look on the other things that we can do with sockets. So for example, maybe we want to make a native Windows socket and see how this works, or we can also create different local sockets which don't communicate over network, which can be just used on a system to communicate between two processes. They also don't have ports. They will, for example, if you use pipes, they will just have a name. Technically it's a named pipe, and then you can connect to such a named pipe from any other program on the same system. On Windows, in fact, you could communicate with named pipes on other computers, so Windows mediates this, but this is just wrapping the pipe communication into a network communication by the kernel and then unwrapping it, so it's usually more reasonable to just go with then using a network communication directly if you want to go over the network to another computer. Named pipes are really mostly useful if you have many processes and you want them to be able to communicate without much overhead. And with regard to Windows, there are also other inter-process communication mechanisms. You could use the directly shared memory. That is a quite advanced mechanism. We might want to take a look on this later. And there are ALPC ports, which are used for the remote procedure call mechanism of Windows. These are not really documented, but they have been quite well reverse engineered, so it's reasonably easy to use those in your own projects. The advantage of using them is that they are even less overhead than a named pipe. And named pipes, since they are a sort of I/O device, they will register, if you have here as a graph for file I/O operation with this third line. This should actually give us a tooltip. It does not. The other I/O, and then this might not necessarily be what you want. So you wouldn't want to cause a lot of something on a computer that looks like file I/O if you don't have to. So it's on Windows an option to use this ALPC ports, but since this is not something that's officially documented, Qt does not offer you any means to exploit that. You would need to do it by hand. If we want, we could actually write our own QIO device-based wrapper class to implement our own communication using such mechanisms on Windows. So we will see if we want to do that, if that sounds like a good plan. But I think, as said for today, since our time is running out and we should not mix too many different concepts, let's just quickly finish the third example with the UDP nodes. Add class C UDP node Qt. Derive it from QObject, and that's it. And it ended up again not where we wanted it, but we can just move it. Right. Okay. We should fix a few things. So actually, we don't need that much to be fixed. We don't need the include at all because now it's included in the precompiled header. We really just need to object UDP node do this, and the other constructor would also be convenient to have. Wouldn't know. So the thing about UDP is that TCP is a stream of data, while UDP are individual packets. But UDP, like TCP, gives you a lot of guarantees. UDP gives you none. The only guarantee you get in UDP is that a packet will either arrive in its entirety or not at all. And of course, having guarantee that something will not arrive is kind of not great, but at least you don't need to care for checking whether the package is not somehow damaged internally. There is a checksum which the operating system evaluates automatically, so if you get a UDP package, you can rely within some certainty. It's not super certain, it's like 1 to 65,000 because the checksum is only 2 byte large, but usually it's good enough. So ideally, if you want, you could add some own verification. But the important thing here is that you don't have a connection. So like with TCP, you have a server and you have a client, and the client connects, and then you have like a mutual connection between those two. There are different packets sent, like establish connection, acknowledge connection establishment, acknowledge that the acknowledgement was acknowledged, and stuff like that. It's a three-way handshake. And even when you are disconnecting, you send a packet saying, I want to disconnect, you get an acknowledge that the other side says it wants to disconnect, and then you're acknowledging the acknowledgement again, so that both sides know that they are now disconnected. So it's really nice and elaborate. In UDP, there is none of that. UDP, by the way, stands just for User Datagram Protocol. The idea is that you can just create your own protocol on top of UDP that does something, and you only have, and the only thing that it offers is the checksum and the port, so that you can dispatch it to different different processes on a computer. So usually, if you are doing something with UDP, you would need some own means of tracking the package, of reassembling data if you want to send more than one package, etc. The size of the maximum size of a UDP package is also limited, so in principle, you could send a reasonably big packet, and then the operating system would break it up and then put it maybe back together. But since there is a risk that the bigger the packets are, and only if one is lost, then everything will be lost. So you should not use UDP packets which are more than the MTU of your network. Yeah, so there are many rules to think about, and here for us it also means that we will want to make this somehow more elegant. So for example, we might not want to specify a port and an address at the beginning. And ideally we would also need to specify at least two ports, because we need to specify the local port and then the port to which we are communicating. In the other example, we had two distinct objects, so each of them just needed one set of informations. Here we will need to provide both. So ideally, for example, the way one would do it is that we would have a something that just starts a socket locally, which doesn't do anything but listens for incoming packets, and then we would have another function like send something to, and then we would want to handle data. So one approach here would be to create an own mechanism to track clients and track incoming connections. And I'm seeing that we will be running out of time, so I don't think we will be able to properly implement this UDP example in the remaining time anyways. So let's think what we could do that can be done in 15 minutes. We could go for something extra simple and just make another client which does not require Qt. That is something that is quick enough. Yeah, let's go with this approach. That will be, in this case, more reasonable. Add folder TCP client winsock. Zack. Since we want to be fast, then let's go copy the Qt client. But we will then be removing a lot of things. VS. VS just stands for Windows Sockets. And it's short enough that it's a nice abbreviation for our use case. Right, so we would not want this to be derived from anything. VS, let's go with capital. It's not a Q object. This does not do anything. This doesn't have a parent. Okay, in this case we really don't need that one. We don't have signals. We don't have anything. Just have a constructor. But to be nice, let's give a function to it. Connect and send. And in principle, we should also not use the Qt addresses here either. We can go with a string. Let's do it like this. Hash include string, and this will be just a unsend short, and here we'll go with a std string address, and we need the address so that we know where to connect to, because that's the client. Right, since that's the client here should not have a default address, because it always needs to know what to connect. Right. So it will be reference, just using this thing will be completely STL and Windows API, so we didn't really save much in fact by doing it like this. VS. Oops. That was a typo. That should be this. Right, and the constructor we can kind of leave empty. We don't really doesn't really need to do anything. Right, so we will add a button. Run TCP client VS. Come on, VS. Then we need to connect that. And we'll need a slot for that as well. VS. 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 Okay, this runs. Then we go to our main function and add another case for client VS. Client VS. We could let's stay with a Qt message box for now. We could switch this to something better later. VS VS client VS. We just create the client and then we want to punct send and connect and address to string to stdv just string, not base string, but this might be a problem with the formatting. Let's put a breakpoint here and see, because we will certainly get the IPv6 formatted. Oh, didn't I save this? Is there a type of name? Client. Client VS, that looks fine. And our not finished UDP node is complaining that it's not finished. Let's quickly finish it. But not really, we'll just make enough that it will not fail compilation queue object. Parent, okay, now it should compile. And we just start the client because we just want to see what we get. And we actually got a nice address, not IPv6 formatted, so we can work with that. Right, so we will need a few includes here. Hash include vs2 tcp iph. Oops. And we'll need winsock2h and erno. And in principle we should also include just Windows 8 so that we have all the other Windows stuff. Right, so and then we need to start the socket vs data vs data vs startup Mac Word 2,2 reference vs data. Once we're done, we need VSA cleanup. And we might want later to improve this, like add multi-threading and stuff like that, because the way we'll do it in this sample, it will do everything just in one thread in a blocking way. So we need a ret, we need a socket, client socket. So this just like socket is a function that creates a socket, af inet, comma sock stream, comma ipep rot tcp proto tcp add phone name that can be set to 0. Oops, I click 0. Name.ai family af inet inet name.ai sock type thing name ai passive. Info Stern Result. Red is equals get add info. This wants now the IP string, so add the string, comma. That should be the port, but we have the port only as a number. That's annoying. Just add an empty string and see if we can fix it later. And name and result. So the idea is this thing will create an address structure. But that makes things complicated. We need to make the port into a string. Since we only have 10 more minutes, let's be lazy. Let's be super lazy. Q string number port. Sorry, that's wrong. No, that's not wrong. Yeah, to std string. That's something we should really improve upon later. And it could be improved, so we could cast this thing on a IPv4 address structure, and then change the port directly. Also, we need to clean up this thing because this will be allocated memory. But for now, we want to be quick. Red connect socket client socket. Let's just call it socket. It's less typing. Client socket result e address comma result. Oops. Result. We have, of course, are missing any error handling. We should we should of course check if this didn't return an error and then bug out if it did. But anyhow, so we have our connect. So at this point we will be connected to the server. Then we can send something. The send command sock, and it just takes a buffer. So let's say hello \n, but we also need to tell it how long it is. And hello is 1, 2, 3, 4, 5, and \n is 6. So 6. And flags, we don't have flags, so just 0. And that says, well, send is always simple. Of course, we haven't checked here again the error, and we should also check the return value. And now we want to receive whatever the other side will reply. So we can just red is equals redsv sock, comma, we need a buffer to receive to char buffer. How big do we want that? 0x. Let's make it 1 page in size and initialize to zeros. So buffer, comma, max len is our size. Is it not implemented? Array size, yep, is implemented. Flags is 0. And then we just print whatever we have received. We should be able to also set whether we want to be blocking or not. So here we can, for now actually we can just put a breakpoint here and see how far we come the way it is. We have problems. I think it doesn't like that we have included also Windows. Some of the things might be already included, so let's yeah, this is better. This should be a semicolon. What was the definition for that? There was a definition you can add to the before including Windows, so that it doesn't include all the stuff, just the most important, but I do not recall. And now, since we are using here some other includes, we get a linker error. And to fix that, we need to add a library that will contain the right DLL imports. Linker input library. So like Qt does it all its own, including vs2 underscore 32 lib. But Windows, of course, does not. So with Windows, you need to include those things manually. So we create our server. We run our TCP client. Oh, and we run here already into a problem. Well, SOC existed. Red was an error. We got an error. Port address. Well, we got an error. We could now interpret what it means, but it just did not like this. Let's see how this is defined. That's a C string. It should be fine. Not quite great. Because the input actually looks valid. Unless let's see. SOC, yeah, that's this thing. Port is just the port. That should be correct as well. Name we have initialized to 0. Family SOC type we are that's wrong. AI protocol. This is the protocol, and SOC type is SOC stream. Yeah. So I guess if we Google for the error code 10044, it will tell us that it's invalid argument. Okay, let's try again. We start the server, we start the client. That worked. Let's see our buffer, and our buffer even contains what? So, as you see, the receive call here is blocking. So, if we would make our server, where is our server? If we would make it wait, Qt add Qt sleep without any specifier. Yes, it's in nanosecond, but let's use sleep ms and give it in milliseconds. Let's say 3 seconds to sleep. We will see if it will still be behave as we expect, or if we run into a problem. But as you see, it's waiting, and only once it received something, it gave us what it has received. So the receive function is blocking. This can be disabled. So if you want it to be non-blocking, that's reasonably easy to do. But of course, the blocking behavior is much more convenient for us, because we then know we can wait until we receive something. The downside is, of course, the data might still be broken up. So another approach would be to make this non-blocking, and then just have a loop running until we have received something. But then the downside is, of course, that such a loop would consume a lot of memory. A lot of CPU. And then we also would not want that. We would prefer our loop to just wait. So here what we would do is to put this in a loop, and then this loop would receive until we know that we have one complete message, and at some point would then break. Usually the way this works is positive values of resv are success, 0 is 0, and negative values are error. So if this is less than 0, then we break. Actually, we could make it even nicer and just put the red here for evaluation. It's not so nice, because we then really want to break instantly. So if let's take with this. It depends how we would want to then proceed. If we need, we want to evaluate this to do something, then we would want this to be kept. And then of course we would need to track the position in the buffer and so on. So the things can get complicated rather quickly. And since we're running out of time for this example, let's just do the last things needed. We want to finish the communication somehow. So first of all, printf %s, comma, we just print the buffer and break, so we don't do much here, but we could do more. And then we want to disconnect, so shut down socket, comma, as the both, so we want to close it properly, 1.0, and then we still, even if we close here, we shut down here, the connection will be closed, but the socket object will still exist, so we want to get rid of it as well. So close socket, and then we clean up the Windows socket stack, and we are done. And we are pretty much out of time for today, so I will upload the recording to YouTube and upload the project to Moodle. And in the next lecture we will I will have to think where we want to start, because we have quite a few construction sites open. We could either make this much better. We still should add a TCP client, a TCP server, WinSock, so without using Qt stuff. We are still missing the UDP things here, and I wanted to still show you the using of local sockets, i.e. on Windows named pipes. And then we had the idea we might even want to implement an own socket object, local socket, an own local socket that would work using ALPC ports. So you could tell me if you find any of those things interesting. Oh, and I see we don't have a homework, so I think it would be a good idea if we make it a homework to just make this work correctly, i.e. add to the buffer until a \n is encountered and then print it. So this is easy enough. You have seen that the Qt version already. Just using pointers should be easy enough as well. You will need a variable to track the position and stuff like that, but all of this should not be too difficult, I think. So to do homework from the 16th 10th 2025, add the data into the buffer until \n is encountered, then print each line. And after the text omit or exit has been and break the loop to close the connection. Yeah, receive that into the buffer until \n, I think. Size t buffer pos is equals null. To track the position to get into the buffer. Also keep in mind to add the len argument of so as to such as to tell the real remaining space in the buffer, and last but not least, when the buffer is full, put no \n encountered and print an error message. Right, so So that will be the homework for the over next lecture. I think it's quite easy. You just need to do some point arithmetics, and then of course some printf with the message and so on. So I think this should be quite manageable. If you have any questions, you can email me at any time. And that's that. So I'll stop the recording.